Here, so we've got the first question for you, Jiri. The software you mentioned is like Contam, or someone that based on or somewhat based on ISO on
Yes.
EN 16798-7.
Yes, thank you for the question. I had no time to explain this. The software I mentioned is the software for calculation the energy need for heating and cooling, and this software is based on the EN ISO 52. I don't remember the name of the standard, the number of the standard, and this is the software for calculation whole energy need, including the calculation of heat loss due to the heat transfer to the building envelope, the ventilation, infiltration, etc., etc. So the calculation of infiltration heat loss is only a part of the calculation included in this software. And I tried to explain that the infiltration heat loss is calculated according to the EN ISO 16798-7. So it's
So that's basically exactly what I presented right before.
yes.
So
yes.
it works like Contam, but that's not directly Contam that is used in the calculation software.
Yes.
It's implemented in a more general software that does the full energy calculation, right?
Yes, thank you.
Yeah. Okay, thank you. And just to make it clear, this EN standard is not an ISO. This is only a European one. And what you mentioned, Jiri, is also the ISO 52000 family, indeed. That is at ISO level, indeed, a general set of standards meant to do the full energy performance calculation.
Yes, exactly. Yes.
Okay.
Thank you for precision.
Yeah, but there is a follow-up to this question. So is it a program that you, Jiri, developed?
No, not me, my colleague. But before
but
this,
your colleague, yeah.
Yes, the software was developed at our university. It is a colleague of mine who is the author of this software. And before this this presentation, I had a discussion with him, and I consulted this presentation with him. So I have the information from the author of the software.
Okay, thank you. But actually, this is not very difficult to implement this kind of software. I mean, the standard itself can be implemented in an Excel file. If you are just one zone, when you start to be multiple zone, it becomes to be difficult. But when it's just one zone, it's very, very easy to implement the standard. And the work has been done to implement the standard in Excel, but you need to use the solver function in Excel because it's non-linear thing because of
Yes, this is not a problem, I think, because the solver is in the Excel. In fact, you can use the Excel itself to resolve this equation. This is not a problem, but the problem is that this equation must be linked with the remaining of the calculation of the energy need or the heat loss, because the heat loss. Ventilation heat loss influences the total heat loss of the building, and there must be an iteration between the calculation of the heat loss and the transmission heat loss and the total energy need of the building, because these problems are linked one together. So to do it correctly, you can no more use the Excel. It needs a more complex tool. So it's not possible, I think, to build up a calculation model hourly calculation model for the calculation of energy need of a building in Excel these days.
Well, actually,
Very complicated.
that was the EPBD wanted that. So they asked for every standard to have an accompanied Excel sheet to be able to put everything in Excel. That was the objective, but in the end they do realize that it was in fact not that much possible because it was way too big, too much interaction and too much non-linear things.
Yes, and this is exactly the problem. This is feasible, but for someone who has a very deep insight into the problematics, deep insight into mathematics and physics behind, and I think this is not the case of the practical of the men who do the practical calculations. They cannot build up such a complex model. It must be prepared by some experts.
Yeah,
it's so complex that this is out of their possibility.
Yeah, so the infiltration rate is feasible when you want to do the full energy performance calculation. That's another issue. Okay, so I think this is more for the general. I just see a new question here on my side. So among the variables considered in the model you presented, there does not seem to be a vertical gradient of internal temperature. Indeed, is this due to an assumption of instantaneous mixing and equilibrium of temperature? Yes, well, indeed, as I said, 16798-7 only consider one zone, and in one zone it's one temperature and one floor pressure. So we do have a variation. Well, the impact of thermal draft is taken into account because the variation of the air density is not the same indoor and outdoor. But indeed, we do not consider gradient of internal temperature within the building. That could be also something that would be, that would improve the model. It would make it quite complex, but indeed, it's not taken into account. It's assume perfect mixing, whatever this may means. Let's ask Andrew Persily about that. So, do you have information, maybe a list, whether the EN 16798-7 is about to be implemented in other European countries as well? So unless someone wants to step it on that, I can try to answer this one. I think all the speakers can switch on their camera now that we move to the full the questions to everybody. So actually, every European countries are supposed to at least take into account EN 16798-7 in their country. But as I said, there are two options, method 1 and method 2. And the method 2 allow to do a simplified calculation and not do the dynamic calculation. So I would say, to answer this question, that every country are supposed to take it into account, but most of them use method 2, which is a simplified calculation. And I have no idea which countries want to move to the detailed calculation and the mass balance equation. This, unfortunately, I don't know. With reference to Xiaofeng's remarks, do you think that in a future of building with excellent airtightness and mechanical ventilation, is it realistic to think that constraints on minimum opening surface will be removed?
Thank you for this very interesting question. I think, I think it's important to, it's important to have excellent airtightness and calculation, so we have more control on the, the air quality and energy efficiency. But I guess it's also very important to have this kind of natural ventilation options in case, system fail or things like that. So I guess the constraints on the minimum opening surface, I think it's important to have that option in place as well in order to improve the resilience of ventilation in the future scenario. So,
well, I'm not sure what that means, but it seems to mean something in the UK. So you've got like a minimum leakiness that you need to have in building, or what is it, the minimum opening surfaces?
I think here opening surfaces, if I understand correctly, is probably more related to the how to say, the opening where are designed for ventilation, for example, natural ventilation, or maybe for windows. Maybe some clarification is needed here. So if I understand, if it is for example, openable, for example, windows, or those probably, I don't know, maybe more vents related, and then I think that should be kept. It should have that option to be able to open them in case the mechanical ventilation fail for some reason. And I'm not sure if that answers that question.
No, but I think it means something different from one country to another. Because if we are in France, for example, you need to have windows in rooms, basically, but you don't have minimum opening surfaces. But it's just that people want to be able to open the windows, but there is no strict requirement on minimum opening surfaces. So actually, we don't have these requirements already in France, for example. I don't know, in Czech Republic, do you have requirements on minimum opening surfaces?
Jiri, you're muted.
Jiri, you are muted. You need to unmute yourself.
Sorry. I don't think we have requirements on minimum openable surface or on opening themselves, but of course we have hygienic requirements on ventilation.
Yeah, but if you've got a ventilation system, you don't need to have a specific design open for natural ventilation if you've got the mechanical ventilations that deal with that, right?
I'm not sure, but I don't think so.
Okay. Okay, we've got 1 additional minute, and then I will need to close this this webinar. Can we find an equation on EN, so that's not the ISO, EN 16798-7 that calculate natural ventilation rate based on recorded wind velocity? Well, yes, in EN 16798-7, according to the opening you have, so natural vents or windows or anything you have, you will get a flow rate according to wind velocity. So yes, you can find it in the standards.
Yes, I would say it's exactly the objective of the standard.
Yeah, that's exactly what it's, yeah, where it points to. But, and not only wind velocity, stack effect also.
Yes.
So in the USA, domestic and many commercial buildings, the windows are sealed without option to open. In many instances, there is mechanical HVAC in those cases. Yeah, also well, in commercial building, in high-rise building also, it may be the case in some European countries. But I think the difference between in Europe is that we've got very different regulation from one country to another. And in some countries, it's maybe mandatory to have a minimum opening surfaces windows, but it may not be in other countries. Okay, passive house have a set percentage of openable windows to allow for ventilation in summer. Also, yeah, the mandatory minimum opening surfaces can also be indeed made mandatory to do ventilative cooling in the summer. So that would make sense, indeed.